Hello dear students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So you know that we have completed PU2 syllabus. Now after completing the chapters, it is very important to measure that whatever we have prepared, okay, whatever we have studied, are we able to solve those questions asked in that KCET examination or not, okay. So thinking that we have started now this PYQ series, so we will be completing all the chapters like last 10-year questions. So we have already done for solutions. So in today's video we are going to discuss the last 10 years top 30 PYQs from the chapter Electrochemistry, okay. So you can expect similar questions in your KCET examination of 2025, okay. So now without any further delay, I want all of you to sit with the notebook and a pen, see the question, try to solve, pause the video and then check the solution, okay. And you can also, like, within 1 hour you can revise 30 questions and that is more than enough, and then you can think that out of 30 whichever questions you are getting correct, so whether this chapter is a weak chapter or a strong chapter, you can easily measure, okay, fine. So the first question is for the spontaneity of a cell, which is correct, okay. So for the spontaneity, for spontaneous reaction, so this question was asked in 2022. I consider this question was very easy, and if you are very strong in concept, if your fundamentals are clear, then there is no chance of any error in this question, okay. So within 15 seconds you should be able to do the question. So for spontaneity, we know delta G should be negative, okay. So correct answer is option number B. Delta G 0 is not there, positive will not happen. Here also delta G is negative, but delta E should be positive, okay. Then this option can also be correct if we have delta E positive value, okay. So that is why the only correct answer is option number B here. Next question, which of the following is incorrect in a galvanic cell? So this question was again asked in 2016, okay. And since it is a theoretical question, it is also easy question, and if your concepts are clear, you need not waste more time, and there is no chance of any error in this question, okay. So which is incorrect, okay. You should be very careful whether it is asked incorrect or correct, okay. That should be what you should be careful while doing the question. So oxidation occurs at anode, that is correct. Reduction occurs at cathode, that is also correct. The electrode at which the electrons are gained is called cathode, that is also correct, because if you remember, we have like this setup, right, for galvanic cell, okay. And what happens here? Electrons are produced, this is your anode, this is your cathode, and here the electrons are gained, right. So the electrode at which the electrons are gained is called cathode, that is also correct. The electrode at which electrons are lost is called cathode. No, here the electrons from which electrons are lost is anode. So the incorrect statement is option number D here, okay. Next question, consider the following electrodes. We have been given with different electrodes. E0 value is given. This question was asked in 2023, the recent question. Then the reduction potential in volts of the electrodes is in the order, okay. So this question, I'll say, might be little moderate because it will take time to analyze all the options, okay. But if you know the trick, you can do it very easily. Now see, reduction potential of the electrode, what is the formula? We know that E0 minus 0.059 by n into 1 by Ag plus log of 1 by Ag plus, this is the formula. Now if you see this, everything is same, E0 value is same, 0.8 volts, so I'll just substitute it. This one is 0.8 volt, okay. Now what happens, n value is how much? 1, right. Here n value will be 1, okay. Now Ag plus concentration we need to substitute. So here I can write like this is your 10 to the power of minus 4, here it is 10 to the power of minus 1, 10 to the power of minus 2 and 10 to the power of minus 3, okay. So now if we have suppose 10 to the power of minus 4, that power goes up, we'll get 10 to the power of 4 and we'll get E0 is equal to 0.8 into, so I'll just do for one, for option number A. E is equal to 0.8 minus 0.059 into log of 1 by 10 to the power of minus 4. Now what will happen? This one will go up, okay. So we will get here 10 to the power of 4, then we'll get 4 log 10, so that is 0.8 minus 0.059 into 4, right? That is what we'll get. Now the same thing will be for all these options, right? So what will be the value for B? For option number B, it will be E equal to E naught, so I can write 0.8 minus 0.059 by n, so that is 1. One second, let me take some space and write down. Okay, so for option number B, it will be E is equal to 0.8 minus 0.059 into, what is the power here? 1, so that will be into 1. For option number C, it will be E equal to 0.8 minus 0.059 into, here it will be 2, right? Then option number D will be E equal to 0.8 minus 0.059 into 3. Right, now you see here you are multiplying a bigger number, so you will from 0.8 this value will be a bigger one, you are subtracting a bigger number here, right? So this value will be the least one. Okay, so you can see where A is least, there is only one option where A is least, and here you see you are multiplying the least number here, right? So you are subtracting a smaller number from 0.8, so that means this value will be the highest one, so B will be the highest one. Okay, B, C, D, A, so correct answer is option number A. You need not solve it. Okay, you can just see here you are multiplying a bigger number, so this value will be bigger, so you are subtracting from 0.8 a bigger number, so this overall value will be a smaller one, and here you are multiplying a smaller number, so this value will be a smaller number. From 0.8 you are subtracting a smaller number, so that is why this overall value will be a bigger number, right? So that is why we will get option number A as the correct answer. Okay, next question. Nernst equation, question is from Nernst equation, Cr2O7. Okay, this question is given, E naught value is given, concentrations are given, and E value is also given. pH of the solution is equal to. Okay, so this question will be was asked in 2014, and it is a lengthy question. Okay, not difficult because of the concept, but because it has lot of calculation, it will be little difficult. So you can easily take 5 minutes in this question, 4 to 5 minutes you can spend. Okay, so now where can be the error? The error can be in the calculation part. Okay, you need to be very careful. So first, if I write the Nernst equation for this one, right? What is E of the cell? 1.067. What is E naught of the cell? 1.33, right? Minus 0.059. Okay, so I'll make it 6 because I can see that the number of electrons is 6. So to make the calculation easy, I'll make it 0.6 divided by number of electrons is 6 into log of, what are the ions present here? This is Cr3 plus, so Cr3 plus concentration is 15 millimoles, so I can write 15 square divided by, here we have Cr2O7, that is 4.5, okay, and we have H plus, so that is 14, right? Now what we can do, we can just write it 1.067 is equal to 1.33 minus 0.01, okay, this is then log of, right? So here I can write this one as 15 into 15 divided by 45, right? I can write into 10 here, then I can write H plus to the power of minus 14, right? Minus 14 I can take. So now if I solve 15 ones are 15 threes are, then 3 ones are 3 fives are, right? So I'll get 50. So now what I have here, I can take this whole thing to the left hand side, right? So what will I get? This whole thing if I convert, so I'll get 0.01 into log of, okay, 10, 5 into 10, so log of 50, okay, and H plus to the power of minus 14, okay, that is there, is equal to 1.33 minus 1.067, okay, so 1.33 minus 1.067. So if you see 10 minus 7 here 3, 12 minus 6, 6, 2, right? I think this is correct. Yeah, we'll get 0.263. Okay, so now we can divide this one 0.01 here, so I'll get 0.263 divided by 0.01, right? So we'll get 22.63, right? 2, I can do it like this, 263 divided by 1000 into 1 by 100, right? So if I cancel, I'll get, sorry, 26.3. Okay, so this whole thing will become 26.3. Okay, so now what I have here, I can write this one as log of, one second, sorry, yeah, I can write this one as log of, yeah. Okay, so log of, there's some error, 1 second students, okay, so I can write log of 50, okay, and this one I can write 14 log H plus, okay, let me erase this part, and 14 log H plus is equal to 26.3. okay. Now log 50, so log 50, how can we do? Log 50 is log 5, right, plus log 10, right, we can write 5 into 10, so log 5 plus log 10. So log 5 is 0.7, here 10, so I can take it as 1.7. okay, so we'll get log 50 as 1.7. okay, 1.7 minus 14 log H plus, okay, is equal to 26.3. Now I'll subtract this one. So what will I get here? See, what I can do is I'll subtract this 26.3 minus 1.7. okay, so 26.3 minus 1.7. So 13 minus 7, I'll get 6 here. Then we have 5 and then 25, right? So let me check, 6 plus 7, yeah, 24 I'll get, sorry. Yeah, 24.6. So we will get here minus 14 log of H plus is equal to 24.6. okay. Now if you know minus log of H plus is nothing, so what I can do, I'll divide this 14 this side. So minus log of H plus is equal to 24.6 by 14. Right. So if you see now, 14 2 is 28, right? So this one will be something less than 2, right? 14, we can say 1s are 14, then you'll del 1.7 something we will get, right? 1.7, 1.8, which will be nearly equal to 2. okay, so I can write here pH is equal to nearly equal to 2. So the correct answer for this question will be option number A here. Okay, so yes, this is a lengthy question, so you need to take here 5 minutes of time. Okay, now, okay, next question will go. So again the question has now from equilibrium constant. So I have seen in this electrochemistry, because the Nernst equation calculations are very lengthy, questions have been mostly asked from equilibrium constant formula. Okay, so you need to revise these two formulas of equilibrium constant more frequently. Okay, now question is given, E naught cell, you need to, is not cell is given, you need to calculate the equilibrium constant. Okay, so this question is easy based, because direct formula based question, you may have error in the calculation part. Okay, because it requires a lot of calculation. So what we can solve it, we have E naught of the cell. So let me change this color, 1 second. Okay, so we have this one, yeah, E naught of the cell is equal to 0.059 by n log of k, right? Now if you see here, H2 to H plus is there and 2Ag to 2Ag, so n factor is 2 and E naught cell value is 0.22. okay, for easy calculation I'll make it 0.6 by 2 is equal to log of k, right? So if I divide, we'll get 0.03, and if I divide this one, 7 point something we'll get, because 3 7s are 21, right? So we'll get 7 point something is equal to log of k, right? Then k will be what? Anti-log of 10 to the power of 7 point something. So now that definitely there will be one answer will be in the power of 7, right? So you can see there is only one option in the power of 7. So correct answer will be option number A. Okay, so the formula here used is this one, so you need to remember this formula. Okay, clear? Okay. Next question, we have given E naught of Fe is given, I2 is given, equilibrium constant again you need to calculate. Okay, so first of all, when such questions are given, this was asked in 2020. Okay, again the question was moderate, calculation error may be there because of the question is very easy, but because of calculation it may take little bit of time. So you can easily spend 1 minute to 2 minutes in this question, but make sure that the calculation is correct. So now if you see, we have first we need to find the E naught of the cell. Okay, the question is asking you to calculate equilibrium constant. The same formula we need to use that we have used in the previous question, that is E naught of the cell is equal to 0.059 by n log of k, right? We need to use this formula, but in the previous question E naught value was given, but here it is not given, we need to find it out. So how to find cathode minus anode? But there is no reaction given to find out cathode and anode. So here you need to remember that the one whose reduction potential is more behaves as a cathode, then automatically the other one will be anode. So if you see here, this is 0.76 and this is 0.55, right? Whose reduction potential is more? Iron reduction potential is more, that is why iron will behave as a cathode, right? So this is your cathode and this is your anode. Okay, so E naught of the cell will be what? Cathode minus anode. So 6 minus 5 1, 7 minus 5 2, so I'll get 0.21, right? Yeah, yes. Now here I'll take it for easy calculation, again 0.06. okay, now here if you see the number of electrons to be used, Fe plus 3 to plus 2 is 1 and I2 to I minus will be 2 electrons, right? Now how can you see? See, Fe 3 plus will undergo reduction, right? Fe 2 plus by gaining 1 electron, but I2 will what? I2 will undergo oxidation, so I minus 2I minus will get converted to I2, releasing 2 electrons, right? So to balance the equation you need to multiply this with 2. Clear? So that is why what I can say, the n factor here is 2 again, 2 log of k. Okay, so now if you divide, this is 0.03 and this will get 7, that is equal to log of k. So what will be k value? K value will be antilog of this one, 10 to the power of 7. So correct answer will be option number D here. Clear? So I'll erase this reaction so that, okay, so that we can see the formula. Okay, this is the formula that I told you already, you need to remember this formula. Now next question, for a cell involving 2 electron change, E naught is given, equilibrium constant. Again the, again the same question you need to use. Again this question is also moderate, calculation error may be there, otherwise this question is very easy. So here if you use the same formula, E naught, now I am not writing the formula, I am directly putting this value. E naught of the cell is 0.059, I will take it 0.06, n factor is given, 2 electron change, so that is 2, so that is equal to log of k, right? Now if you solve it, we will get 0.3, so 3 by 0.3, right? 3 by 0.03, 1 second. Yeah, we have 3 by 0.03 is equal to log of k, right? Now what will happen, if you solve this, we'll get 10, that is equal to log of k. So what is k value? K value is 10 to the power of 10. Okay, so correct answer for this question will be option number D. Okay, and the formula, again the same formula is required. Next question, we'll go for now Faraday's law. Okay, very important here. So this question, 1 liter of solution of MgCl2 is electrolyzed completely, okay, this word is important, by passing a current of 1 ampere for 16 minutes and 5 seconds. The original concentration of MgCl2 in the solution was, see, now you had a solution of Mg chloride and then you have done it complete electrolysis. Okay, so that now the question is asking what is the original concentration, means how much mass got deposited, that must be the original concentration, So we need to calculate how much mass is deposited. But after that, one more step is there ahead that we'll discuss. This question was asked in 2019. Question was moderate, big calculation error can be there and little tricky also. Okay. So now see Faraday's first law we need to use. So if you remember Faraday's first law formula, we have M is equal to ZIT, where Z is equal to molar mass by N into 96500. Now if I want to calculate M, okay, first is what? Z, that is molar mass 24 divided by 96500 into 2. Okay, I is given 1 ampere. Then if you see time, 16 minutes means 960 seconds plus 5, so that is your 965 seconds. Okay, so now if I solve this, we will get 12 here, and this one is 100, right? So I'll get 0.12. I hope this is clear. So mass is 0.12. So this much mass was present in the solution. But the concentration, the question is not asking about the mass. It is asking you in terms of concentration. Means we need to find the molarity here, right? So what is the molarity? Number of moles. Volume is 1 liter. So let us calculate molarity here. Yeah, we'll substitute for molarity now. Here, that is what I'm taking is the trick was present, right? You need to remember that here only concentration is not asked, sorry, only mass is not asked, concentration is asked. So that must be converted to concentration. So we have here given mass is 0.12, molar mass is 24 divide into 1, the volume in liter, right? So we have, so this is we need to solve. So we will get here, I can write it like 1 by 2 into 10 to the power of minus 2. So we'll get 0.5 into 10 to the power of minus 2, right? And now if I solve this, I'll get 5 into 10 to the power of minus 3. Okay, so correct answer for this question will be option number A. Okay, very easy question, but this part was where the students may not understand it and do it correctly. Okay. Next, the charge required for the reduction of 1 mole of MnO4 minus to MnO2, 2018 question. So again Faraday's law, oxidation number calculation, if you are done, if you are able to do it correctly, then this question will be very easy. MnO4 minus to MnO2. So here the oxidation state is +4. You can see X, let me like MnO4 minus, right? Let manganese be X. Each oxidation state is -2, so 4 oxygens are there, so it will be -8, and the total charge of the compound is -1, so I'll get +7, right? So here manganese is in +7 oxidation state. Now if you see MnO2, right, this is X and this is oxygen is -2, so 2 into -2 is +4, right? So we will get +4, okay? So MnO4 minus to MnO2, 7 to +4. Okay, so what is the change? How much Faraday is required? 3 moles are required. So the answer here will be 3 Faraday, option number B. Okay. Next question. By passing the electric current, NaClO3 is converted to NaClO4 according to the following equation. Okay, fine. How many moles of NaClO4 will be formed when 3 Faradays of charge is passed through NaClO3? Okay, so if you are giving, question is again in 2017. Okay, this is like easy question, but a little bit of understanding is required. If you have practiced such questions, then it is a damn easy question. Okay, now see here. Question is asking, this is the reaction, okay? NaClO3 gets converted to NaClO4. So, if you give 3 Faraday of charge to NaClO3, then how many moles of NaClO4 will be produced? That you need to calculate. So, we need to check now if 3 moles or 3 Faraday of electricity is given to NaClO3, then how much NaClO4 will form? Okay, that is what you need to calculate. Now, if we see this one, see. First we need to see what to convert 1 mole of NaClO3 to 1 mole of NaClO4, how much charge we need to give. Okay, that is what you need to first calculate. Now how to do that? We need to check the oxidation number here. So if I see NaClO3, okay, and I have here NaClO4. What is the oxidation state of chlorine here? Sodium is +1. Chlorine, let me take it as X, and this is -6. We will get here total net charge is 0. So X is equal to +5. So I'll get chlorine charge here is +5. Now if you see here, this is sodium is 1, chlorine is again x, and this is minus 8 is equal to 0. So x is equal to plus 7. Okay, so now plus 5 to plus 7 is 2, right? So how many moles of we require? 2 Faraday. So that means what I say is, to convert, see, we need, for converting 1 mole of NaClO3 to NaClO4, okay, we need 2 Faradays. If you give 2 Faradays, then 1 mole of NaClO3 will get converted to 1 mole of NaClO4. So I can say with 2 Faradays we can convert, we can get 1 mole of NaClO4. Right? Now the question is asking if it is giving 3 Faradays, right? So if it is 1 Faraday, then how much I'll get? Half mole of NaClO4. If it is 3 Faraday, then I'll get 3 by 2, right? See, 2 Faraday is giving you 1 mole of, so if you give 2 Faraday of electricity to NaClO3, we will get 1 mole of NaClO4, right? You are giving 2 Faraday of current or charge to NaClO3, and that will give you 1 mole of NaClO4. Now if you give 4 Faraday, then we will get 2 moles, but if you give 3, between 2 and 4, right? So that means 3 Faraday if you are giving, we will get 1.5, right? We'll get 1.5 moles of NaClO4. So correct answer here will be option number C. Okay, if you are clear, once again I am saying C. To this, suppose C, I'll just erase it and do it again. This will do it diagrammatically. Okay, what we understood here, let us little bit understand with the help of a diagram. Okay, so now you see, if we have, see, NaClO3 is present. Okay, now what you gave? You gave here 2 Faraday of current to this one. Now this got converted to what? NaClO4. Okay, clear? So 1 molecule or 1 mole requires 2 Faraday. Okay, now if you give 3 Faraday, okay, then means what? 1 mole is getting converted with 2 Faraday, another 1 mole you have given. So that will form another half molecule. So already 1 was formed with 2 Faraday. Now with 1 more Faraday, half molecule is formed. So 1.5 we will get NaClO4. Okay, or you can do in unitary method. Very easy is unitary method. That is 1 mole of NaClO3 requires how much? 2 Faraday. 2 Faraday is required for 1 mole of NaClO3. Then 3 Faraday will be how much? 1 by 2 into 3. That is 1.5. Okay, so option is C correct is the answer. Next question. This is also from Faraday's law. Current Faraday required for the reduction of this one to this one. Same question but little tricky here. Oxidation number, if you know correct calculation, see, Cr2O7 2 minus, right? So the oxidation state, let us for chromium it is X. So 2X minus 14 is equal to minus 2. So we will get X is equal to plus 6, okay, right? And that is getting converted to Cr3 plus, right? So we have here, so how much is required? 3 Faraday, okay, but you need to be careful here. See, if you balance the reaction, we will require 2 Cr3 plus. Here 2 chromium is there. In 1 molecule of potassium dichromate or dichromate, there are 2 chromiums. So both the chromiums will reduce. For 1 chromium, we need 3 Faraday. 2 chromiums are there, means we will require 6 Faraday. So correct answer here will be option number C. Here there is no 3 Faraday in the option, so that is why it is less confusing. But if you have 3 Faraday and 6 Faraday, you may do wrong here, right? So remember, when chromium dichromate is there, 2 chromiums are there, means both the chromium will get reduced, right? You cannot reduce only 1 chromium there. Each chromium requires 3 Faraday. So 2 chromium will require 6 Faraday. I hope you are getting this one. Okay, next question. 2015 question, and the similar question was repeated in 2024 as well. Okay, how many coulombs of electricity are required for the oxidation of 1 mole of water to dioxygen? Okay, so here Faraday's law, and you should know the reaction of oxygen to water. Okay, that is important. So sorry, water to dioxygen. So how will I see? Dioxygen is there. 1 mole of water. 1 mole of water, H2O. What is the charge of oxygen? 2 minus, right? That will give you O2. How will it give you? So 2O2 minus, okay, 2O2 minus or I'll do it with one only. Wait one second. Okay. So we will get this by releasing 2 electrons. Okay, we can get one oxygen will release both the electrons, then it will become O, right? By releasing 2 electrons we will get, so how much is required? 2 Faradays, right? 2 Faraday is required. Now if you see 2 Faraday means you need to multiply with 96500 to convert it into coulombs, right? So how much will get? This much will get, so we can write 1, 2, 3, 4, 5, 1.93 into 10 to the power of 5, that is option number D here. Next question in 2024, a similar question is asked with 0.1 mole, okay. So if you have seen for 1 mole, we have just seen calculation for 1 mole I need 1.93 into 10 to the power of 5. For 0.1 how much I will require? Just multiply here 0.1, so that will be 1.93 into 10 to the power of 4. So correct answer here will be option number B, okay. Easy question. Next question number, this question was also there in 2024, okay. Current of 3 ampere is passed through molten calcium salt for 1 hour 47 minutes and 13 seconds. The mass of calcium deposited is, okay. So this is again very direct question from Faraday's law. Calculation part you may do error, okay. So if 30 seconds to 1 minute I can take, you can do this question. So if you see M is equal to ZIT, so Z is what? 40, okay, by 2 into 96500. Now current is how much? 3 ampere, okay. Time we need to calculate properly. See 1 hour is what? 3600 seconds. Time should always be in seconds. Next we have 47 minutes, so that means 47 into 60. So how much will be that? 6 sevens are 42, 6 fours are 24 plus 4, 28, 2820. Okay. Next we have this 13 seconds. So if I add, we will get 6433 seconds, okay. So let us check once again. 1 hour 3600, 47 minutes into 60 seconds, 6 sevens are 42, 4, 6 fours are 24 plus 4, 28, 2820 and then 13 seconds, right. So we'll get 6433 seconds here. So just multiply 6433, okay. So if you solve this, you can directly get the answer, and this answer will be around 4 grams. So correct answer will be option number D here, okay. Next, this formula already we have discussed. Next question number 15, now towards batteries, okay. A device that converts the energy of combustion of fields like hydrogen and methane directly into electrical energy. So this we know, definition based fuel cell. Very easy question, and there is no chance of any error here, okay. You should not do any mistake in this type of question. Hardly 15 seconds is enough to solve this question. Next, in a dry cell, which of the following is the electrolyte? Again, this is also very direct theoretical based question. More than 15 seconds is not required, but since 13 seconds you need to read the options. So answer number C, ammonium chloride is the catalyst used in the, electrolyte used in the dry cell. Next, in fuel cells, dash are used as catalyst. Again, this question was asked in 2022. Again, very easy question, platinum and palladium, option number C, okay. Next, secondary cell is one in which? So again, this question also very super easy, asked in 2016, because theoretical based question, no calculation, within 15 to 30 seconds this question should be done. So can be recharged by passing current in the same direction, can be recharged by passing the current in the opposite direction, that is option number C, just definition based question. Next, while charging the battery, while charging the lead storage battery, okay, you are charging it, means you are doing reverse reaction, okay. So in reverse reaction, what happens at cathode, okay, oxidation takes place, and at anode reduction takes place, right. So cathode reduction not, because at cathode oxidation, anode oxidation no. Here anode is reduced to Pb, this can be there, and PbSO4 on cathode, okay, one second, at anode there is reduction, right. PbSO4 on cathode is oxidized to Pb, okay. Now you see here, Pb, what is the oxidation state here? +2, right? And here it is 0. So +2 to 0, it is undergoing reduction. The statement is correct. And at anode, reduction is happening. That is also correct. Now, if you see here, PbSO4 on cathode is oxidized. Here again +2 and here 0. +2 to 0, is it oxidation? It is reduction. So from this statement only we can eliminate this one. Correct answer will be option number C here. Okay, very easy question. Next, again fuel cell question, 2015 reaction you should know. Here H2 is kept at anode and O2 is kept at cathode, right? So what happens? O2 undergoes reduction and H2 undergoes oxidation. So O2 reduction reaction is this one. Okay, so correct answer is option number A. Again 2015 question, easy question if you know the reactions. Okay, so once again let us see the reaction here. At cathode, right? Cathode oxygen undergoes reduction. Here the oxidation state is 0. Here it becomes -2, 0 to -2 reduction. And H2 undergoes oxidation. Here it is 0 and here it is H plus. So this is the reaction. Okay. So next question number 21. For hydrogen oxygen fuel cell at 1 atm and 298 Kelvin. Okay, this is given 240. You need to calculate E naught. So this question has been taken from fuel cell, but the concept is of delta G. Okay, Gibbs free energy. So we have this formula, means equilibrium condition. E naught is equal to 0.059 by N. Okay, 1 second. You need to, okay, yeah, Gibbs energy. So we'll do it again. Yeah. So we have been given with Gibbs free energy and the question is asking you to calculate E naught of the cell. So this question is easy, direct formula based calculation. You need to little invest time. So if your calculation is correct, within 1 minute you should be able to do this question. So we have what? Delta G is equal to minus NF E naught of the cell. Delta G value, remember here one more thing of chances of mistake, unit. Okay, you need to convert it into joules. Okay. So minus 240 into 10 to the power of 3, okay, and in fuel cell N factor is 2, right? 2 into 96500 is equal to E naught of the cell. Okay, now if you solve this, we will be getting around 1.24 volt. So correct answer for this question will be option number B. Okay, fine. So you can see this formula we need to use. Next question, during the electrolysis of brine by using inert electrode. So 2023 question, products of electrolysis is also a major topic. So if you remember, brine solution had was Na plus, Cl minus, H plus and OH minus, right? So these two will move towards cathode, right, and this will move towards anode. Chlorine oxidation potential is more, so chlorine will undergo oxidation at anode to liberate Cl2. So correct answer is option number D. Okay, this is also a very easy question, theoretical based question, less than 30 seconds is enough. Next, if an aqueous solution of NaF is electrolyzed between the electrodes, the product obtained at anode is. So if you again see, we have Na plus and F minus, we have H plus and OH minus. Okay, now at anode, so this is what? Plus charge, so they will move towards cathode, which is negative electrode, and these are negative charge which will move towards the positive electrode, that is anode. Now here OH minus oxidation potential will be more, so O2 gas will be produced at anode. Correct answer will be option number C. Okay, again this is also 30 seconds is enough, easy question if you know the theory. Okay, next question. An aqueous solution of copper sulfate is subjected to electrolysis during using inert electrodes. The pH of the solution will. Okay, now see, aqueous solution of copper, right? So you have Cu2 plus and you have SO4 2 minus and you have H plus and you have OH minus, right? So what will happen? These two positive charge, they will move towards the cathode, okay, and these two will move towards the anode. Now if you see here, copper 2 plus, okay, copper 2 plus is what? Undergoing reduction, okay, and H plus can also undergo reduction. So reduction potential of copper is 0.34 and that of H is 0. So that means here copper 2 plus will undergo reduction. Okay, that means what? H plus concentration will increase. If H plus concentration will increase in the solution, pH of the solution will decrease. So correct answer here will be option number C. Okay. Next question. So this is 2019 question. This is also, I'll say, easy to moderate. You need to relate the reduction of copper and hydrogen with the hydrogen ion concentration. Okay, so therefore it becomes little bit tricky. Okay. Next, in the electrolysis of aqueous solution of chloride solution, which of the half cell reaction will occur at anode? So you have what? Sodium chloride aqueous solution. So Na plus, Cl minus, H plus, OH minus, right? So here what is there? This two will move towards cathode, this one will move towards anode. Now chlorine, as we said, has more oxidation potential, so chlorine will lose electron to give you Cl2 gas. So you can see here Cl minus is losing electron to give you chlorine. So correct answer is option number A. Okay, so this question again is a theoretical easy base, more than 30 seconds is not required. Fine. Next question will go towards the conductance, where majority of the questions like formula based questions have been included. Okay. The specific conductance of 0.1 m HNO3 is 6.3 into 10 to the power of minus 2. The molar conductance of the solution is. Here what happens, the question is easy, okay, but formula is also easy, but you need to understand the terms correctly, okay, which is specific conductance, which is molar conductance. So please watch my electrochemistry part 2. We have discussed this in part 2, I think part 2 or part 3, where I have explained the terms. I have made a table and given you the terms so that you can revise and memorize all the terms. See, when I was a student, I face problem in this. I used to get confused with which is specific conductance, which is molar conductance. The units are almost same, right? So that is why you can revise them again and again. Okay. Now if you see specific conductance, what is kappa? This is specific conductance is kappa, and we need to find molar conductance. So direct formula we have lambda is equal to kappa into 1000 by C. Right, so I'll substitute first. So you can see the formula that is required here is kappa into 1000 by C. So we will calculate lambda m. What is kappa value? 6.3 into 10 to the power of minus 2 into 1000 by C. C is again what? 10 to the power of minus 1. Okay, so we will get here 630. So correct answer will be option number C. 630. If you solve this, we'll get option number C. Okay. Next question, the molar conductivity of is maximum for the solution of concentration. So 2022 question, this one. Again, this is very easy question. You need to know molar conductance formula. If your concepts are clear, then there is no chance of error here. Okay. So if you see lambda m, again the same formula is required, right? So what I can say, we need highest molar conductivity. That means what? Concentration should be least, right? Inversely proportional. If you see the option, this is the one where the concentration is least. So correct answer will be option number B here. Okay, fine. Next question, the resistance of a 0.01 molar KCl solution at 298 Kelvin is 1500 ohm. If the conductivity of 0.01 m KCl solution at 298 Kelvin is this much, the cell constant of the conductivity cell is. Okay. So this question was in 2021. This is easy formula, direct formula based question, but common mistakes I can tell that you can do in the calculation part. Okay. So now if we see what is the formula to be used, R is equal to rho into L by A. We need to use what? We need to calculate the cell constant. So cell constant will be equal to what? I can write R by rho, right? R by rho. This cell constant is L by A. So I can write R into 1 by resistivity is nothing but kappa, right? R into kappa. So R is 1500. Okay. And this one is 0.1466. Okay. Into 10 to the power of minus 3. Okay. Now for some easy calculation, what I can do, this one I can consider as 0.15. Okay, for easy calculation, and this one I can consider as 1500 into 10 to the power of minus 3. Okay, so I can write, again I'll write it like 15 into 10 to the power of minus 5 I'll make it. Okay, for more easy calculation. See, how can we make it easy? Yeah. Okay. 15 into 15 into 10 to the power of minus 5. Now 15 square, all of you know, 225, and here we have 00, 10 to the power of minus 5. So 1, 2, 3, 4, 5. So somewhere around 0.225 we will get. Now you see this is too much more than 291. We need 225. 2, this is nearer. So correct answer here will be option number A. Okay. Next question, the pair of electrolytes that possess the same value for Debye-Huckel-Onsager equation. This question is in 2020 and it was repeated in 2024 as well. Okay, so this is important question and this concept you should know. So if this concept is known to you, it is given in the NCERT book as well. If this concept is known to you, then this question is super easy. What you need to do, you need to find the same value of A. So you need to remember that for same electrolytes, the A value is same. Now what I mean by same electrolytes, cation and anion should have same charge, should have same charge. Okay. Now let us see option number A. Here you see NH4 plus and NaCl. Okay. Now sorry, this is what type of electrolyte? This is also, and here also you have Na plus charge and Br minus, same charge, right? So these two electrolytes will have same A value. Okay. So here I made a small mistake. Wait, it's not that they should have same charge. See, what do you mean by same electrolyte? Let me define you correctly. See, same electrolyte I can say, not same electrolyte, same type of electrolyte means if their cation and anion charges are same. Means suppose see, we have one electrolyte AX, another electrolyte BY. Okay, if A is plus and B is also plus 1 and A is X is minus 3 and B is also minus 3, their cation charges are matching, their anion charges are matching. In that case we can say that AX and BY are same type of electrolyte, and for this type of electrolytes the A value will be same in the Debye-Huckel-Onsager equation. Okay. Now for example, you see here it is plus 1 minus 1, here also plus 1 minus 1. So their cation charges are matching, anion charges are matching, right? If you see here, this is Na plus 1 but Mg is plus 2. Their cation charges are not matching. So that is why this cannot be the answer. Here if you see, this is Na plus 1. Again calcium is plus 2. Cation charges are not matching. So that cannot be there. Now Mg is plus 2, Na is plus 1. Their cation charges are not matching. So this cannot be there. So correct answer will be option number A here. Okay. Next question, the same type of question was asked in 2024 as well. You need to find the value of same A. Okay, the same concept should be there. So if you see Na is plus 1, calcium is plus 2. Cation charges are not matching. This is not the answer. Now if you see here, we have calcium is plus 2, magnesium is plus 2. Cation charges are matching. Anion charges, if you see, chlorine is minus 1, sulfate is minus 2. Anion charges are not matching. So this is also not in that category. Na plus 1, potassium plus 1, cation charges matched, chlorine minus 1, bromine minus 1, anion charges is also matching. So this can be the answer. Next one you see, cation charges plus 2, sodium is plus 1, again cation charges are not matching. So this is not the answer. So correct answer will be your, so let me write the option A, B, C, D, option number C. Okay, C is the correct answer. Clear? Next question number 31. At a particular temperature, the ratio of molar conductance to specific conductance of 0.01 m NaCl solution is. See, this question is again easy if you know the formula. There should not be any error. Numbers are also very easy for calculation. You can spend at least 1 minute to see the options and do the calculation. Okay. So what is their molar conductance formula? Kappa into 1000 by C. Okay. So we need ratio of molar conductance to specific conductance, that is lambda m by kappa we need, right? So that is 10 to the power of 3 by, and what is concentration value? 10 to the power of minus 2. So that will become 10 to the power of 5. Okay. Now what is the unit of here? S centimeter square mole inverse, and kappa value is S centimeter mole, S centimeter, right? Only S centimeter. So S centimeter inverse, sorry. Now if you see what will be the unit here, we'll get centimeter cube mole inverse, right? Centimeter cube mole inverse. So 10 to the power 5 is the answer, so we can eliminate these two options. But here if you see the units are different, so correct answer will be option number A. Okay, so here what mistake you can do? You can do mistake in knowing the units correctly. Okay, so that is why for this electrochemistry chapter, all the terms and their units should be known to you. Okay, so yes, so we have discussed almost the most important top 31 questions I can say for electrochemistry. So you need to now practice all the revision, you need to revise all the formulas and do these questions, and you need to do similar questions. Okay, so please practice similar questions so that your speed will increase, your calculation will increase. Okay, so that's all in this video. In the next class we'll be doing chemical kinetics numericals. Okay, so I hope this series is helping you, and all the very best for your KCET preparation. And any doubt in any question, do not forget to comment down. I'll definitely address it. Okay, thank you for watching once again, and please subscribe the channel and please join our WhatsApp channel to get all the PDF notes and everything. Okay, thank you and see you soon in the next class.